Something is moving under Lake Michigan, and it is not seasonal ice, not ship traffic, and not anything the Midwest was told to expect. Sensors are picking up cracks in the lake bed that look like the first lines of a split, and the agency that watches quiet ground just raised a red flag. If a stable lake can break, what else that we trust as solid is getting ready to shift? The alert no one expected. The region around Lake Michigan is supposed to be calm. It sits far from the big fault lines. People build skyscrapers, tunnels, water plants, and bridges there because the bedrock is old and steady. That belief is why the alert from the United States Geological Survey shocked local officials. Satellite images, lake floor sonar, and a dense line of underwater sensors all showed the same thing. New fissures were opening in the central basin of the lake, and they were opening faster than normal sediment shifts can explain. These were not small surface cracks from waves or ice. They started deep in the rock. The main fracture stretched for more than 15 miles according to the first model, and many smaller branches ran out from it like ribs. Some of those branches ran toward the western shore where millions of people drink, fish, and ship every day. Even stranger was the pattern in the data. Readings taken in March did not match the readings taken a month later. The strain across the lake floor was higher. The cracks were under stress, and the stress was not easing. Micro-quakes that people on land could not feel were shaking the basin every few hours, and those quakes lined up with the fracture map. To the scientists watching, it looked less like erosion and more like a rift system waking up. Rifts are places where the crust pulls apart. They are common in East Africa and under Iceland. They are not supposed to grow under a Great Lake. That was the reason for the red alert. It did not mean an instant disaster. It meant the process under the water was no longer slow enough to ignore. Once a crack forms in rock under that much weight, water and sediment can push into it, widen it, and connect it to other weak spots. Each connection changes pressure across the basin. Change the pressure enough and the lake bed can heave in some places and sink in others. Engineers who plan water intakes, power tunnels, and ports have to know if the ground under them will stay flat. Suddenly no one was sure. Local planners were told to treat the lake floor as active terrain, not fixed ground. That alone changed emergency maps overnight. For now, however, field teams sent submersible drones from Milwaukee and Musken to see the fractures directly. They filmed long dark slots in the lake floor where sediment had dropped away. Fine bubbles were rising from several of them. Gas tests later showed methane and carbon dioxide, both common in deep rock but unusual in this amount for this lake. Gas release means pathways. Pathways mean new water routes. Put together, the picture was clear. The base of Lake Michigan was changing shape. If the base keeps changing, how long can the waters and the cities around them pretend nothing is truly wrong? The old scar under the lake. To find a cause for the new cracks, geologists looked backward. They went to maps of the Mid-Continent Rift, a billion-year-old tear that curves through what is now the Great Lakes. That rift once tried to split North America before it froze in place. Its deep rocks are still different from the crust around them. They are denser, more brittle in some layers, and laced with old magma bodies. Most days none of that matters. But if weight on the crust changes or if stress from the mantle shifts even a little, those old weak zones can start to move again. Lake Michigan sits right above one of those zones. When ice sheets covered the region, the crust flexed downward. When the ice melted, it rose back up. That rebound is still happening, and new climate patterns have added a twist. Rapid swings in lake level change the load on the lake bed faster than nature used to do it. Heavy years push down. Dry years let the ground spring up. Rock does not like to bend back and forth. Sometimes it breaks. That is the working theory many teams now share. Ancient rift plus modern rebound plus water load equals fresh fractures. The problem is the scale. The main crack the USGS mapped is longer and deeper than what those gentle forces usually make. It looks more like a structure that wants to link to other faults and form a system. If it becomes a system, pathways will open for water, gas, heat, and possibly even warmer material from deeper crust. Sonar scans already hint at warm spots. Thermal images taken over several weeks showed patches on the lake floor a few degrees hotter than the areas around them. That is not lava. It is most likely fluid moving through rock and carrying heat upward. Every geologist who saw that data wrote the same note. Active. Active is a rare word to see in reports about the interior of North America. It means the rock is changing now, not in some far past. It means measurements taken this month will not match next month. It also means the forces below are not fully mapped. That is why teams in Chicago, Green Bay, and Muscon began to share data daily. They need to know if a crack under mid-lake could shift stress closer to intake pipes, tunnels, or even to the sand foundations that hold up harbors. A slow tilt of only a few millimeters can change how water flows, how ice forms, and how breakwaters handle storms. Engineers can design for waves. It is harder to design for moving ground. The rift story is clear enough for scientists, but how do you tell the public that a lake floor once called stable is now classed as a fault zone that has to be watched? Water, gas, and fragile systems. Once the fissures were confirmed, attention moved from theory to impact. Lake Michigan is not just scenery. It is a water source for Chicago, Milwaukee, and many small towns. It is a shipping route, a fishery, and a thermal sink for power plants. A crack that taps deep rock can change the chemistry of that water. USGS and university labs tested samples from near the largest fracture. They found slightly higher methane, carbon dioxide, and sulfur compounds than normal offshore readings. Those levels were not dangerous yet, but they proved that the lake bed was venting from depth. If venting grows, the water above a fissure can lose oxygen. Fish avoid such zones. If the venting includes metals or hot fluids, treatment plants have to work harder to keep water safe. Most plants were built to stop microbes, not deep earth leaks. At the same time, satellite ground deformation data showed parts of the western shore lifting by millimeters. On their own, such uplifts do not crack roads or break pipes. But over years, combined with lake bottom flexing, they can shift the stress on buried lines and intake tunnels. Engineers along the Chicago to Milwaukee corridor have already been asked to model what happens if the lake floor sags in one sector while the coast rises in another. That kind of uneven motion can pull joints apart or push bridge footings out of alignment. Ports and marinas could see depth changes that do not match dredging plans. All of this is made harder by climate swings. More intense storms and rapid lake level drops and rises load and unload the crust faster. That gives the new cracks fresh pressure cycles to work with. Ecologists watching the deep parts of the lake added another concern. Fissures can become new habitats. Microbes that feed on methane live in such sites. They form mats that support unique food webs. That sounds positive until the new web takes oxygen from nearby waters and stresses fish that local economies need. Add in the chance of algae blooms from altered nutrient flow and the picture gets complex fast. Every piece of the lake system is tied to every other piece. Change the bed and in time you change the fish, the beaches, the intake pipes and the people who depend on them. City officials want to secure water. Fisheries want to secure spawning zones. Power companies want to secure coolant flows. Homeowners want stable shorelines. The science teams want more instruments on the lake bed to see what is really happening, but that costs money and time. Meanwhile, the fractures do not wait. They widen bit by bit under hundreds of feet of water where cameras cannot watch all day. That is why the USGS called for round-the-clock monitoring and why emergency planners asked a harder question. If a slow split turns sudden, how much warning will anyone actually get? Signs the crust is waking up. Seismologists around the Great Lakes keep long records of tiny quakes. Most of the time they are rare and scattered. After the Lake Michigan cracks were mapped, that pattern changed. Clusters of micro-quakes began to show up under the central basin and along the line of the oldest rift. None of them could knock a glass off a shelf, but together they drew a picture of rock that was slipping in small bursts. This is how rifting begins in other parts of the world. First the rock stretches. Then it breaks in narrow zones. Then the breaks link. Only in active zones the steps can happen in months. In a place like Lake Michigan the steps should take centuries. Yet the rate of events in 2025 looked more like a young rift than a dead one. That made researchers review old reports from the 18 and 1900s about odd shaking near the lake. When those events were plotted on modern maps, many sat right on top of the new fissure system. That suggests this part of the continent has tried to move before but never had the instruments in place to catch the full story. Add in new electromagnetic readings that show the stress field around the basin changing shape, and the word reactivation no longer sounds dramatic. It sounds accurate. If a buried rift is waking, even slowly, then more cracks, more gas vents and more ground warping are likely. That does not mean the lake will split in two in our lifetime. It does mean the background hazard level for the whole region just went up. Insurance models, building codes, pipeline routes and even wind farm plans will have to adjust. Cities that thought of earthquakes as a West Coast problem will have to plan drills. People do not love hearing that message, but it is better than being surprised by a larger event. Seismologists often say the Earth gives warnings. Here it is giving them under a veil of water. Some groups have asked if the current cracking could trigger slides on the lake floor. Underwater landslides are rare here, but when loose sediment sits on a slope and the base shifts, it can drop. If that happens near a shore intake, the rush of mud can clog pipes. That is another reason the monitoring must grow. Scientists in Canada and the United States have proposed a joint task force because the Great Lakes are shared waters. A moving lake bed does not stop at a state line. But coordination takes time and the lake is already moving. Please like and subscribe channel.